Hello and welcome. Today we're going to look at circular motion. Firstly, with circular motion, if we look at the car here, is this car traveling at a constant speed or is it accelerating? Now you can think about it as you look at it. Most of you would say that it's traveling at a constant speed. Now the next question is this car busy changing its direction? And then that's obvious. Okay, we can see it's traveling in a circle. So does this car have a displacement? If it goes in a circle and starts and ends at the same place, then there is no displacement. So since the car is traveling in a circle, if it starts and ends at the same place, no displacement. Okay, so what is acceleration then? We know that acceleration is the rate of change in velocity, right? So is that car changing its velocity? You say there's a constant speed. So velocity is a vector quantity that has a magnitude and a direction. Speed is the magnitude part of the velocity, but the direction is very important. So therefore, if something has a constant speed, but its direction is changing, it is still accelerating because its velocity still changes. Now if we look at this again, we see that there is a constant speed, but a change in direction, therefore a changing velocity, and a acceleration. Now, although this car is traveling at a constant speed, it's still accelerating. Are you confused? Yes. And the reason for that is we're trying to define a circular concept with a linear definition. So what we'll learn in AS physics is how we define circular motion. But circular motion is kind of a different topic to normal motion in the fact that the direction constantly changing messes us up with our definitions as we have it at the moment. So what causes the circular motion? To do that, we're going to be looking at the force involved. Whenever there is circular motion, there's a force keeping the object in a circle. This force is called the centripetal force. Centripetal force means the center-seeking force. The centripetal force can be changed by changing the mass of the object, the velocity at which the object is moving, and the radius of the circle. So if we look at our picture again, although this car is traveling at constant speed, still accelerating. Okay, so here the force is keeping the object in circular motions always towards the center. Okay, so we can see that the red force is towards the center. We can see there that there's a green acceleration. Acceleration, according to Newton's second law, is always in the direction of the resultant force. And the velocity at which the object is moving depends on the force at any given moment. Okay, it's perpendicular to that force. So at any given moment, the velocity is perpendicular to the force, which means if we had to cut the string at a certain time, it would just move perpendicular from where the force was at the moment that the string was cut. Here we can see that the object moves directly downwards the moment the string is cut. So yeah, if you've got any questions on this, remember it's a very easy basic topic and in IGCSE, so if you've got any questions, please let me know.